trapezium OABC. Okay, so before I label the vertices, it's important that we sort of look at the information carefully so I label it correctly. And if you notice here, it says that CB is parallel to and twice as long as OA. So with the trapezium, of course, you've got a pair of parallel sides, so it's OA is parallel to CB. So these two sides are the sides that are parallel. So I'm going to need to start with OA here. So that side OA will be parallel to this side, which is CB. So if I go in order, then OA, B, so going around clockwise, OA, B, C here. Okay, so OA is parallel to CB, or CB is parallel to OA, and it says that it's twice as long. So when I drew this, I made this side twice as long as this side, just so I got a decent perspective of it. It says then the points D and E are the midpoints of A, B, and C, B respectively. So if I go for the midpoint here, roughly there, that will be D, midpoint of A, B, and then E then will be in the middle here. Okay, so then we're going to find the vectors, okay, in the question, but let's put in what they give us as well. They say that OA is equal to little a, and OC is equal to little c, and of course CB, we can put that in there somewhere, is double that. Yeah, maybe I won't put it in because I've got E there. I don't want to really confuse myself here by putting an arrow in, but that will be 2A, yeah, because it's double that length. Okay, so let's go for it then. So CA is in part A. So CA is basically asking us to that line there, yeah. So if you want, you can draw it in. So this vector here, CA. Now if you think about it, CA is formed, you can go along here and then here. So you can do these two vectors to create CA. So CO plus OA. So CO along here and then OA here. So along here is minus C. If you go this way, because this is the opposite, isn't it, of OC. And then plus A that way. So you've got minus C plus A. You can write that as A minus C if you want. B then, we've got to work out AB. Now let's think about AB. You've got to get from here to here. Now I don't know what this side is, obviously, because I'm trying to work it out. But what you can do is maybe go the long way around to get from A to B, to get that displacement. So A to O plus O to C plus C to B. Now A to O is the reverse of this. It's going backwards, so it'll be minus A. O to C will be that little c there. And then C to B, okay, will be, remember it was parallel and double that, so plus 2A. So we have A then plus C, okay. C then, we're asked to work out ED. So ED is this vector here. Okay. Now, how do we create E to D? Well, we could go E to B plus B to D. So we go along here and then here. So E to B plus B to D. Now, if you think about it, E to B from here to here, it's like half of C to B, yeah? So we could write that down to start with. And then B to D is like half of B to A. This is the midpoint. And the good thing is we know what CB is. We know CB is 2A, yeah? And we also know what BA is because we've worked it out. I say worked it out, we worked out what AB was, yeah? So we know AB is A plus C, so BA will be the reverse of this, so the minus of this. So I can just put the same thing in but change the signs. So I get then, this will be A, of course, minus half A minus half C. So I get half A minus half C. And we're done for ED. So then hence show that CA is parallel to and twice as long as ED. Well, let's look at ED, because ED is the sort of awkward one here, isn't it? ED with the fractions is half A minus half C. You can see there's a factor there of a half. So if I take that out, factorize it. Now what I hope you notice is, we know what CA is up here, A minus C. When I factorize out a half here, I've also got A minus C here, haven't I? So I could rewrite that as ED is half CA, because that's CA, isn't it? Now what you see is ED is a multiple of CA in terms of the vectors. Now when we have that, when one vector is a multiple of the other, it's parallel. Okay, so we proved a parallel because ED is a multiple of CA. In fact, ED is half of CA, but I could just do a bit of algebra here, take that 2 over to the side, and I get 2ED is equal to CA. And then I proved what they've shown what they've asked us to do. Yeah, we've shown that CA is parallel and twice as long as ED.